What is hepatic extraction ratio? This refers to the fraction of drug removed from the body in one pass through the hepatic circulation. Whenever you give a drug, it gets injected into the circulation, it passes by the liver, and assuming it is metabolized in the liver, a certain proportion of the drug you have given is going to be taken up and metabolized and removed from the circulation, and then some of that drug will remain in the circulation. So you're going to remove a certain proportion or a certain fraction. This is a hepatic extraction ratio. Each drug has its own extraction ratio, which is determined by different factors, and there are three categories. The three categories we can break this down into are those with high hepatic extraction and those with low extraction, which can subdivide into those that are highly protein bound and those with less protein binding. And examples here are propofol and lidocaine. So what happens with drugs with high extraction is that free drug in the plasma is rapidly removed, and this allows drug that is bound to protein to be released from the protein binding. So the free drug is removed, and this encourages the molecules that are bound to proteins to dissociate from the proteins into the plasma. Now, this initially absorbed molecule is metabolized so quickly that it then has capacity to also extract the drug that you've just released from the protein binding as well, and that gets metabolized too. This process is so fast that the degree of protein binding of the drug itself doesn't really matter, because it's all being pulled off the proteins so quickly that it's not really an affecting factor anymore. What really matters is hepatic blood flow, and that becomes the limiting factor. So these are flow or perfusion dependent. So if a drug has high extraction ratio, the limiting factor is perfusion, and therefore we say their extraction in the liver is perfusion dependent. And it's unsurprising that drugs with high extraction undergo very high first pass metabolism, i.e. if you take it orally, then you absorb it into your portal system, goes to the liver, and most of it gets metabolized straight away, so they have very poor oral bioavailability. When we come to the low extraction drugs, we see the opposite. As blood passes through the liver, some of these molecules are taken up and they're metabolized, but most of them bypass because there's not enough capacity, the metabolism isn't quick enough for these molecules to be mopped up too. So the perfusion doesn't matter too much because the blood flow is not the limiting factor. And these drugs classically have better bioavailability when taken orally. For drugs that are minimally protein bound, this means that neither protein binding nor perfusion to the liver are going to affect the rate of metabolism very much at all, because the limiting factor is the hepatocytes themselves. For drugs that are highly protein bound, it's a little bit different. If your drug molecules are highly protein bound, it means only a very small proportion of the drug is actually free in the plasma and able to have a clinical effect. If the rate of metabolism is low, and the blood flow to the liver is not having a huge effect, this means that any changes in protein binding become very significant, because you will have rapid proportional changes in the amount of free drug if you suddenly take away or add more proteins for the drug to bind to. So if you suddenly add a bunch of protein for it to bind to, you're going to mop up all these spare molecules and have very little left to do anything clinically. Likewise, if you have a sudden drop in your protein, you'll have a lot more of these molecules freed up, and you can actually have a dangerously high plasma concentration. And a particular example in this category would be phenytoin or diazepam. So, low extraction means not perfusion dependent. Low extraction with a highly protein bound molecule means protein binding is very important in determining the free plasma concentration of your drug. Low extraction with minimal protein binding means neither of them really have much effect. High extraction, such as propofol or lidocaine, means very quick uptake from the blood, very quick dissociation from proteins, and therefore drug metabolism is perfusion dependent. So a question you can get asked either in the MCQs or even in the SOE exam are what factors affect hepatic extraction ratio? And so you can tell here that perfusion is an issue, so we'd say blood flow to the portal system, uptake into the hepatocyte, and then the actual ability of the hepatocyte to metabolize it, so the enzymatic capacity to metabolize the drug. So these are the three factors that will affect how well a drug is metabolized, and then those are the categories that you need to be able to talk about in the exam. And we usually think of first pass metabolism as being quite annoying because it gets rid of the amount of useful drug that we have to do anything with, but actually it can be very helpful, and an example of this is with codeine. So when you take codeine orally, you absorb the codeine into your bloodstream, into your portal system. It then travels to the liver and it gets metabolized there by CYP2D6, as we mentioned in our previous video, to morphine. So then morphine is actually the drug that we want in the bloodstream, and so we've just produced a whole bunch of this in the liver. So this is an example of when first-pass metabolism is actually very helpful, and it's the same for enalapril, the blood pressure med. That is a prodrug, which is then metabolized into the active compound, which actually does the clinical work. So this is basically what you need to know for hepatic extraction ratio, which does come up in the exam, and it is really helpful if you can explain it succinctly.